Welcome to Math with Professor V. Last week I gave you some homework. I gave you about 8 problems to work on and decide whether or not you needed to use integration by parts or u-sub to evaluate each of the integrals. So now I'm going to go over the homework. So get out your solutions. Let's correct as we go through and tell me how you did in the comments down below. So first integral we have indefinite integral of e to the x times sine of e to the x dx. Right away, I notice I have a composition of functions, sine of e to the x. And then the derivative of the function inside that composition is being multiplied right out here. So it seems like a perfect time to go ahead and use u-substitution, not by parts. So let's give it a go. We're going to let u be that inside function, which is e to the x. And then du would be its derivative, e to the x dx. And I have exactly that. Now when my students are first learning u-sub, I have them draw this little kidney bean. So du is e to the x dx, and I have them come over here and say, show me where e to the x dx is. It's right here. And it always looks like some sort of deformed kidney bean. But anyways, all of that is going to be replaced with, yes, du, and then we have sine of u. So rewrite your integral, all in terms of u, sine of u du. Very good. Now from here, we can just go ahead, evaluate. Antiderivative of sine u is going to be negative cosine u plus c. And then you want to go back. Our original variable was x, so don't leave your answer in terms of u. No. Negative cosine e to the x plus c. All right. Now, would integration by parts have worked? No, it would have made things a disaster. So no matter how you slice or dice it, u and dv, say, I wouldn't recommend letting dv be sine of e to the x, so say you let u be sine of e to the x, and then dv is e to the x dx. Then du, derivative of sine e to the x, would be cosine e to the x times e to the x dx. And v would be just e to the x, antiderivative of e to the x. And then look at what we're left with. uv would be e to the x sine of e to the x minus integral e to the x squared cosine of e to the x dx. Things have gotten significantly worse than where we started, right? And sometimes you have to just go through the process to see and convince yourself. But I'm here to just kind of guide you and give you some tips too along the way, so it doesn't have to be so painful. All right, I put 2 and 3 side by side so you could see the difference. I'm going to do 2 first. I have a composition of functions again, right? I have sine of x cubed, and then what's the derivative of x cubed? 3x squared. I don't have exactly that sitting outside, but I certainly have close enough. X squared, we can make that work. So let's do a u-sub. Let u be x cubed, and then du is 3x squared dx. Now what do I have? All I have is x squared dx. So I want to make that match exactly what's on the right hand side here. So I'll divide by 3, then 1/3 du equals x squared dx. Beautiful. Now I'm ready to rewrite the integral all in terms of u. I have 1/3 sine of u du. Fabulous. Antiderivative, we just did one super similar. It'll be negative 1/3 cosine of u plus c. And then u was x cubed, so this is negative 1/3 cosine of x cubed plus c. Perfect. Okay, I want you to see how that's different now from number 3. Again, I have something being multiplied by sine of x. But do you see here how this is sine of x, this is also x. The derivative of x is just 1. I don't have that sitting out here. See how we had x cubed and then this was 1 degree lower? Or if this had been x squared and x, I still could have done the u-sub. But if the power matches, then I'm stuck. I'm stuck. U-sub won't work, okay? Did you sit there and try it? Yeah. So in this case, we have to do by parts. So we're going to pick u and dv. And what I always tell my students is you want the product v du down here to be as easy as possible to integrate. So when you're picking u and dv, I'll tell you right now what you don't want. You don't want this one to be sine of x and this one to be x dx. Don't write this down. Because dv, antiderivative of x, would be 1/2 x squared, right? And then du would be cosine of x, which means I'm going to have to end up integrating 1/2, oh, don't forget the dx, x squared cosine x dx. And that's making things worse, right? Because see, we just had x to the first and now we have an x squared in the integral. So that's not the way to go. How do you make sure that doesn't happen? Well, you put x over here as u. That way when you take the derivative for du right here, it'll be just 1 degree lower. So x goes here. Usually your polynomial goes there. And then dv is going to be sine x dx. You see? Then du is just 1 dx. And v, antiderivative of sine x, is negative cosine x. All right, perfect. Now we're ready to go. So let's rewrite this using our by parts formula. We have u times v, so that'll be negative x cosine x minus integral. This is going to be v du. But you see how there's already a minus sign here? Then I'm going to switch this to plus cosine x dx. Perfect. So negative x cosine x, that's already taken care of. Antiderivative of cosine x. Very good. Positive sine x. Think to yourself, whose derivative did I take to get cosine x? And then plus c. And we're done. Okay? Good. Make sure you see the difference. So if the power here is the same as the power outside, u-sub won't work, right? It has to be 1 degree lower in order for u-sub to work, because when you take the derivative, it goes down a degree. Okay, very good. Let's move on. All right, again, I want you kind of to have them side by side so you can see the difference. All right. Number 4, u-sub or by parts. If I have a choice, I always like to go for u-sub first, right? Because you learn that first. It's a little less work, typically. Do I have a composition of functions? Well, I have something squared, and inside I have another function. Yes, natural log of x. So let me think here. If I'm going to make a u-sub, remember, you let u be the inside function. Is the derivative of natural log of x sitting somewhere here, being multiplied? Why, yes, 1 over x dx is right here. So let's go ahead. I'm going to let u be natural log of x. And then du is 1 over x dx, which is right here. Beautiful. So if I rewrite my integral now, I'll have u squared du. That's it. Oh, this one's relaxing. So antiderivative is going to be 1/3 u cubed plus c. And then just go back, replace u with natural log of x cubed plus c. That's it. Very good. Okay, now let's compare that with number 5 over here, x times natural log of x. So if we try to do the same u-sub and let u be ln of x, do I have du? Do I have 1 over x dx sitting there? No. And then, please, don't ever make the most pointless substitution ever. You'll never let u be x. If you let u be x, all you're doing is changing up the letters that are in the integral. If u is x, du is dx, don't do it. There's no point. It's not going to change the nature of anything, okay? So then I'm like, oh, it must be by parts time. Okay, u dv. When you have a natural log, that's usually u, because natural logs, if we let them be dv, we have to find their antiderivatives, and they don't have nice ones. And the way we find the antiderivative of natural log of x is by integration by parts. So typically there's an ln, I just go bam, that's going to be u, and then that means dv will be x dx. All right. Then let's see now. So du, derivative of ln of x, 1 over x dx. V is antiderivative of x, so 1/2 x squared. Fabulous. Okay, so now let's see here. We're going to have uv, that's sitting outside the integral. So 1/2 x squared ln of x minus integral, do you remember the formula? V du. I don't know if you can see that. V du comes next. So let's write it out slowly. We'll have 1/2 x squared times 1 over x dx. All right, 1/2 x squared ln of x. Let me take the 1/2 outside. Integral. X squared divided by x. One of them will cancel, so I just have x dx now. Oh, that one's no big deal. Antiderivative of x is 1/2 x squared. So I'm going to add another 1/2 in the front and then plus c right away. And then last thing, just clean up those constants. So 1/2 x squared ln of x minus 1/4 x squared plus c. How was that one? Good? Favorite one of the day? Yes, quite nice. Okay. Everything's looking good. Let's move on to a few more. Now I wanted to work with inverse trig functions. Okay. So the first one, we have 1 plus tan inverse of x over 1 plus x squared dx. If you didn't memorize the derivatives of your inverse trig functions, then you would be stuck here. But I know derivative of tan inverse of x, derivative of tan inverse of x, or arctan of x, is 1 over 1 plus x squared. And I see exactly that right here. 1 plus x squared is in the denominator. So I'm going to let that be u. But in fact, I'm not going to just let u be tan inverse of x. I'm going to let u be 1 plus tan inverse of x. Because why not? If there's a constant, throw it in with the u. Watch. When you take the derivative of a constant, it's 0, right? So then it's just going to clean your integral up so nice. Boom, the 1's gone. So then we're just going to have integral u du. Yeah, see? If you had only let u be tan inverse of x, you would have to split it into 2 integrals. More work. Don't do it. Don't do it. Okay, antiderivative of u. 1/2 u squared plus c, and then this is going to be 1/2 1 plus tan inverse of x squared plus c. I would leave it alone, box it, and move on with your day. Thank you very much. Good? Okay. Now number 7, we have integral of cosine inverse of x. And much to my disappointment, I don't see the derivative of cosine inverse of x being multiplied anywhere. So we have to do by parts. And by parts is very commonly used for functions like this. So I don't know the antiderivative of cosine inverse of x. So it would make no sense to let it be dv. It has to be u. It has to be u, cosine inverse of x. And then dv is just going to be plain old dx. Okay. So derivative of cosine inverse of x, it's very much like sine inverse's derivative. It just has a negative. So negative 1 over rad 1 minus x squared dx. You do have to have that memorized, right? Otherwise, you're just going to be stuck. Stuck. And then v is plain old x. So here we go. We have u times v, which will be x cosine inverse of x minus integral v du, which has another minus. So I'm already going to switch this to plus x over rad 1 minus x squared dx. Okay, good. So this is taken care of. We don't have to integrate this. Now I'm turning my attention here. Wow, I have a composition of functions. Underneath the square root, I have 1 minus x squared. And I'm going to need to make another substitution. Yes. the derivative of 1 minus x squared is negative 2x dx. I kind of have that, right? I have x dx. If I'm off by a constant, we can fix that. That's no big deal. So I'm going to go ahead and make a substitution. But remember, we already used up the variable u. So we got to pick somebody else. Pick somebody else. Let's pick t. So let t be 1 minus x squared. dt will be negative 2x dx. So negative 1/2 dt is x dx right here. Okay, so let's rewrite what we have. X cosine inverse of x plus integral. X dx is negative 1/2 dt over rad 1 minus x squared, which is going to be rad t. Okay, I know it looks disgusting. I'm going to rewrite it in just a second in derivative-friendly format. So this is x cosine inverse of x. I'm going to take this negative 1/2 outside minus 1/2 integral t to the negative 1/2 dt. Beautiful. So this is x cosine inverse of x minus 1/2. Antiderivative of t to the negative 1/2. You're going to add 1 to the exponent. So now it's going to be t to the positive 1/2. And then I divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2 over 1. And then plus c. And then lastly, boom, boom, those cancel. And then let's go back to our original variable, because I can't leave that t to the 1/2 in there, certainly not. X cosine inverse of x minus, all right, square root 1 minus x squared plus c. Boom. So we needed by parts at first, and then u sub, or t sub in this case. I put this on my exam 1 for Calc 2 this semester. Yes, I did. Some of them did great, some of them not so great. So it is what it is. All right, last one. I told you needed to do both techniques again, but this time in a different order. So this time you're going to do the u sub first, or I'm telling you do a t sub, and then by parts, okay? So you have integral x to the 5th e to the x cubed, and in my hint I said break up x to the 5th so that it's x squared times x cubed e to the x cubed dx. So we're going to start off, let t be the exponent, x cubed. All right, so let t be x cubed. Then dt is 3x squared dx, which I kind of have, right? It's kidney bean time. Let's draw the kidney bean. X squared dx. Okay, so I'm going to divide by 3 over here. So 1/3 dt is x squared dx. Perfect. So integral 1/3. Now what about this extra little loser x cubed? He's not a loser. Be nice, Professor V. Okay, that's t. That's t, right? Okay, so 1/3 times t times e to the t dt. Take a second. Are you good? Are you all right? This is t right here. I will draw arrows for you. Maybe that will be helpful. This is t, e to the t, and then the other part is the kidney bean. Okay, good. So now it's time for by parts. Aha. So who should be u and who should be dv? Remember, I want the row below it, du times v, to be as easy as possible to integrate. So let u be t. In fact, let's put the 1/3 with it. 1/3 t, and then dv will be e to the t dt. So then du is just 1/3 dt, and v, e to the t. Very good. Okay, so let's put it all together. We have now u times v, so that'll be 1/3 t e to the t minus integral v du, which is 1/3 e to the t dt. And then this, not a difficult integral to do, 1/3 t e to the t minus 1/3 e to the t plus c. And then remember, t was equal to x cubed. T was x cubed. So let's replace and go back to the original variable. 1/3, that's a very ugly 3, my apologies, 1/3 x cubed e to the x cubed minus 1/3 e to the x cubed plus c. And if you're feeling somewhat sketched out about your answer, you can always take the derivative and make sure you get back the original problem. So that concludes the integrals that I assigned for you. If there's some other topic you need help with and you want more homework, you let me know. I've never had people ask me for homework. Actually, that's not true. I have a few students in my Calc 1 class that ask for extra homework on top of what I give because they just want more practice. They're little machines. So I'm happy to oblige. Give the video a thumbs up, subscribe if you haven't already, and you can check out the rest of my playlists and videos that are organized by course. So I have Pre-Calc, Calc 1, Calc 2, Calc 3, etc. The playlists are all in order. And you can also follow me on Instagram, TikTok, and Twitter, Math with Professor V. Thank you guys for your support. Love you all. I'll be back soon.